My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 632. In this lecture, I will continue my discussion on code example cats versus dogs. You can actually get the whole code here. Just see here. If you click on this, link here, it will open up very nice snippet here, which will tell you how this simple model is trained. Just let me click on this. What will you get? How this simple model is trained. Your first model is very simple model where you are training a simple neural network from the scratch. You are training a simple neural network from the scratch. How does the convolution neural networks looks like, which is I can say, which is sequential one. That's what it says. Model equal to sequential convolutional layer. You have model dot add convolution layer activation. You have model dot add activation. ReLU, you are adding max pooling. Model dot add max pooling. This is one layer of convolution activation and max pooling. There is another layer. This is another layer of convolution. You can see the convolution activation and max pooling. Again you have convolution activation and max pooling, isn't it? Just see again convolution and max pooling. Just if you observe here, model dot add flatten data, dense connections, model dot add dense connection, activation. I can say you have activation, you have something like dropout. What is your activation? Your activation is sigmoid because I have two classes, isn't it? A dog or cat, isn't it? That's why we activation is sigmoid. I have two class classification, and my loss is of course binary. Loss equal to binary underscore cross entropy. Binary cross entropy, nothing but two class log loss. It's a two class log loss. Optimizer is RMS prop, and metric is, what is your metric? Metric is accuracy. And of course I will train this model and run it. The whole code looks like this. I have a batch size of, what's my batch size of 16. Image data generator. Just see, I have image data generator, training data. I have training data generator, test data generator, isn't it? And at the end of it, I will run the code. I will run the code, and at the end of the running, the code I am running I can say it's a bunch of, I'm running it for what's your batch size? It's a batch size is 200, isn't it? Batch size of 200. I'm running it for how many epochs? I'm running this for 50 epochs, things like that. So I will get an accuracy. If you observe carefully, I will get an accuracy of 0.79 to 0.81 after 50 epochs, approximately 80% accuracy is what I get if I training my neural network from the scratch. You see, if I what accuracy I will get. I have it basically approximately, I can say approximately 80% of accuracy what I get if I training my own neural network from scratch. And remember, I have very little data. That's important. Remember, I have very little data, so I can't train very complex complex VGG16 like networks, isn't it? I will simply overfit them. If I do it, what happens? I will simply overfit them. So if you use simple small convolutional network from scratch, you are getting 80% of accuracy with literally how many lines of code? with literally 40 lines of code. That's important. With literally 40 lines of code, isn't it? That's how the simple Keras is, by the way, isn't it? A simple Keras. So this is your, I can say this is your classical convolutional neural network training. Let's go one step further. What if I use the bottleneck features in pre-trained network? That's important, isn't it? Let me repeat. Let's go one step further. What if I use the bottleneck, but the bottleneck features in pre-trained network? Pre-trained network, I showed you what are the bottleneck features. Bottleneck features are all the features. What are the bottleneck features? What if I use bottleneck features in pre-trained network features? What happens? What are the bottleneck features? Bottleneck features are all the features except the top layer. That's important. We already discussed this many times. I just remove the top layers. I will use these as my convolution features. I will train another model. On top of it. How do we achieve it? There is a very nice code snippet here. Again, if you click on this, let me just click on this. Let's go to GitHub again. We have very nice code snippet. The most important line. Just if you see the code in GitHub, the most important line in this code is I'm saying my model is from, what is this? My model is from applications folder, which is 16 model, and here I am saying include underscore top equal to false, and I want the weights that have been generated from training on ImageNet. When you say include underscore, when you say include underscore top equal to false, what it eventually do for you is it will give you the whole VGG. It will give you the whole VGG network except the top layers, everything else. It could give now I will use this model to generate my CNN features, isn't it? I will use these to generate my CNN features and my final model. Just say I will use this. I will use this model to generate I will use this model to generate my CNN features, and my final model will be like this. I'm actually generating two functions here. One is save underscore bottleneck features. Just see, my first function is save underscore bottleneck features, where each image is taken, and I generate the bottleneck features and I save it. That's important. I'm saving it to .npy file, isn't it? And then there is other function where I read all of the bottleneck features for each. Just see, there's other function. Just train underscore top model. This is the other function where I read all of the bottleneck features for each of the data point. That's what is that? Train underscore top model. Then I build a simple multi-layer perceptron. I can build a simple multi-layer perceptron on top of it. Isn't it? What is this? Model equal to sequential model dot. Just you can understand all this. The model dot add flatten, model dot add dense, model dot dropout. All these things we discussed. Model dot compile. All these things. I have flatten layer followed by dense layer, dropout, dense. This is multi-layer perceptron, isn't it? What I have done, isn't it? Well, just check this one. This just try to understand till this stage, so that I will continue my discussion on code example for cats and dogs in my next lecture also. That is in lecture number 633. Thank you very much.